Hello guys and welcome back to my channel. In the last video, we are looking at the up amp and voltage divider and circuit. So that's what we looked at in the last class. So today we'll be doing a project. We'll be doing a shadow detector. That's the name of the project we're doing. So a shadow detector is a device that will be able to detect when somebody passes. It detects purpose. And, okay, so we'll be doing the simulation, and you can actually gather the component and build it, and it's going to work exactly as it worked here when you follow all what we follow this. So what we'll be doing today is based on everything we learned in the last class, which is voltage divider and the operational amplifier. So they are what we are actually going to use. So let's have a quick review on what we learned last. So in the last class, so we learned about the operational amplifier. So this is the operational amplifier whereby this pin here is the non-inverting input, which is the Vin plus, and this other pin is the inverting input, which is the Vin minus. So you apply voltages to these two pins. So if Vn plus, which is this now, so you note it by seeing this plus and this minus, okay? If Vn plus, if the voltage at Vn plus is greater than Vn minus, then V out is high. Okay, so whenever the voltage here is greater than the voltage here, V out is high. Then if Vn plus is less than Vn minus, V out is low. Whenever the voltage here is greater than the voltage here, this one is what is low. It's as simple as that. This is the basic and the simplest explanation that I can actually do on this, and you can understand it very well. Okay. All right, let's look at the voltage divider. The voltage divider has two resistors connected in series, okay, where you have the R1 and the R2. So if you are putting your V in here and the output here, this output is dependent on this formula here, okay. Then if R1, which is this one here, if R1 is increasing, V out is reducing. If R1 is reducing, V out is increasing. That means this R1 is inversely proportional to our V out. Okay, whenever it is increasing, V out will be increasing. Then, likewise, R2. If R2 is increasing, V out is increasing. If R2 is reducing, V out is reducing. Meaning that R2 is directly proportional to our V out. So these are the basic things that we've learned, and we're making use of all of them. So let's hop over Proteus now and remove this. So the sensor we are going to be working today to be detecting the shadow is a sensor called LDR, light dependent resistor. So we're going to be using this that is active. This simulates on Proteus. Okay, so this is an LDR, light dependent resistor. So this thing now is actually a resistor, but its resistance now depends on the amount of light falling on it, on the rays of light falling on it. When the light falling on it increases, the resistance reduces. But when the light falling on it reduces, the resistance will increase. That means by the day is going to, the resistance will be low, and during the night the resistance will be high. Do you understand? So that means when someone casts shadow on it, the resistance will be high. When the shadow leaves, the resistance will be low. Okay, so this is a picture of this LDR. This is how it looks in real life. So it's a sensor. Okay, this is where the light falls, and it's two pin. It doesn't have polarity, just like a resistor. But the resistance is dependent on the amount of light falling on it. So that is this man now. Okay, so now we're going to use this man to create something. We're going to use this man to create something. So to creating something with this man, we are going to be putting this man with resistors in series to create a voltage divider circuit. So let's see what we'll do. Let me add the resistor here now. Okay. This resistor now is serving as R1, while our LDR is serving as R2. Okay, so I'm going to power them with a battery now. Let me use the battery to do this. So see what we are talking about here. Okay, so let me reduce this voltage to 5 volts. And then let me bring a voltmeter, a DC voltmeter, and connect it to this V out. Okay, so now let's simulate. Right now, we have a whole lot of shadow on this. Okay, now let light fall on this man. Now let's see. If light is falling on this man, you see the voltage is reducing. Um, if darkness is falling when the light is going, you see the voltage is increasing. But if light is falling, you see the voltage is doing what? Is reducing. Why is the voltage reducing? Because when light is falling on this man, the resistance will be reducing. And remember, whenever the resistance of RO2 reduces, the voltage reduces. And when the resistance increases, the voltage increases. And when shadow is falling on it, the voltage is doing what? Increasing. So I want us to note this. This is one. So let me do this again here. I'll keep the battery by the side. Another resistor here. Okay, this time around, the LDR will be the no, let me keep it this way. Okay. This time around, the LDR will be the R1. Okay, while my resistor will be the R2. Let's see the different behaviors we're going to get. All right. Then let's simulate this. Okay, so now you see there is darkness on this and the voltage is very low. Then let's apply light. If light is falling on it now, you see the voltage is increasing. But if darkness is falling on it, the voltage will be reducing. Okay, I made this 5 volt earlier, so let me make this one 5 volt as well. Okay, so if light is falling on it, the voltage will be increasing, but as darkness is falling, the voltage will be reducing. You see that I've actually created two different scenarios that can be used in two sensor conditions. I can actually use this one now to monitor light. I can use this to monitor light, and I can use it to monitor what? Darkness. Because this very one now, when darkness is falling on it, the voltage is increasing. So I can actually use that as simple as that. Then I can use this one to monitor light because when light is falling, the voltage is doing what? Reducing. I can use either of them for either purpose. I can use this for light and darkness. I can still use this for light and darkness. But for easy understanding, you see how you can actually use it. So this is just how the voltage divider. So you see that we've actually turned a sensor behavior into voltage, and this voltage is what we're going to now apply to the operational amplifier, and applying it to be able to do what? Use it to achieve what we want. So remember that what we want to achieve is a shadow detector, device that detects shadow. Okay, so let's keep this out because we've already talked about using this. Okay, so keep the other one out. Let me remove these other ones, they are not necessary. These two are necessary now. Okay, so I will get my op amp. So this is my op amp. Now this output, the question now is where will I put this output? Now remember that when shadow is falling on this man, the voltage here is reducing. And what we want is whenever the voltage here increases, we should have a high here. And when we go back to what we will have about the op amp, whenever the Vin plus is greater than Vin minus, then output is high. That means this place should go to the Vn plus because it is what we want it to increase, then we will not have high here. So we'll just put this place direct to the Vn plus. And then what are we going to put in the Vn minus? We are going to put what we call a reference voltage here. Okay, we'll just pick a voltage that will be very constant and put here. I can just use two resistors and get a constant voltage and put here. But then I can use a variable resistor. The reason for using a variable resistor is if I want to change the reference point at each time, okay, I can use it to tune the sensitivity at each time. We're going to see that when we begin to test this. So let me put the variable resistor here. This is a potentiometer, okay. I have it here. My This is my reference voltage and this is then the voltage I'm monitoring. Okay, so I'm just going to use our VCC to be here and to be here as well, and then connect the two grounds. Okay, this will also be in the VCC. Okay, then connect the two grounds, connect the ground here, and then this will also go to the ground, and then I'm going to connect an LED here. I'm going to connect an LED here. Okay, so remember that our interest is when the output is what? Is high. Okay, so let's simulate. So upon simulation, the output is what? Is high. Okay, then for us to understand the behavior of this, let's put a DC voltmeter in the two terminals. Let's put a DC voltmeter. Let me use this for here. Let me use this for here and use this for here. Okay, let's use a DC voltmeter and there should be in the ground and the ground. So as you can see, the voltage here is actually greater than the voltage here. Okay, though there is still light. We want when we have enough darkness. Are you with me? Then we'll have what we want. So let's say this is the light now. We need to increase this other voltage. We need to increase this other voltage. Okay, so that at some point the LED should be low. So let's increase the voltage as we are looking at the value. Okay, it's off now. Okay, let's increase it a little bit to around 4 points. Yeah, it's now in 4 points. So now there is enough light on the LDR now. Let's darkness start falling on the LDR. No, this is, we are not getting over. Let's increase this a little bit now. So that when enough darkness falls on this, not just more darkness. So let's fall darkness now. Let's keep reducing. So you can see that immediately this sees darkness now. This LED will turn on. Now let's apply light. It goes off. Let's apply darkness. If you can still vary the sensitivity that we want it to maybe come on when enough darkness must have been, maybe total darkness must have been on this man. Are you with me? So what you just need to do is to keep varying this man to make sure that this voltage is, the voltage here is greater than the voltage here. Whenever the darkness comes, the voltage here is greater than the voltage here. So when you make this device, you are going to tune it according to your own specification and then set it the way you want. So at this point, we've been able to develop a shadow detector. Okay, let me apply light. So there is light on this now, and when you apply shadow now, our LED turns on. So with this, there are various other projects you can actually do with just this. Okay, this other detector, you can develop an automatic night light. You can develop intruder alarm using shadow. When someone's shadow pass, it will give you alarm. So these are different projects that you can do. So I just leave it up to you to try some of the projects. Always reach out to me when you are done with anyone. You need recommendations. Always reach out to me and let's see what you've done and more you can actually do with this. So stay tuned on this channel, like this video and subscribe to our YouTube channel because we are bringing you more projects on basic electronics, things you can do with this up amp and the voltage divider that we find. So stay tuned, like the video and subscribe. Thank you for watching. Have a good day.